y'all. In this video we're going to look at the square root function and graphing it using transformations. So the square function is y equals x squared. Domain, I could put any numbers in for x, so all real numbers. The range, because it's squared, even if I put in a negative, say I put -2 in there, -2 times -2 makes +4. So our range for this one, if it hasn't been shifted anywhere, is from 0 inclusive, because square root of 0 does make 0, up to infinity. It's an even function, and that's why they're called even functions, is because this is a square root with a 2. Vertex form for a quadratic or a square function is right here. This, if you look at it, looks kind of familiar, hopefully, from the transformations that we did earlier. HK is going to be what the vertex, which is this part here at the bottom. It works the same way in terms of transformations, though. If this shows as a minus, that means it moved right, and it shows as a plus, that means it moved left. The K on the outside is going to be the vertical shift, so up and down. And so you can kind of see that if we take this point and we move it, left 3 and up 2, that's the same shifts that we're now calling the vertex for this particular function. A is still the vertical stretch and compression. And then the parabola opens up if a is greater than 0 and opens down, so this way, if it's less than 0. And that holds with what we saw with reflections. Remember, if we put a negative in front of this, that flips the direction of the function and it would open down. So all things we've seen, just with a new picture. In terms of graphing this on the computer, you'll need the vertex and one more point, especially if it has a stretch. Like I would just use this point and this next one to wherever it's been stretched to. On paper, it can help to have that next point over. So for me, over 1 up 1, over 1 up 3. So it's the reverse of the square root. So let's go ahead and graph these. I will just do a quick that much. That's our parent function. And this one is asking us to graph that down 3 units. So we would come down here to -3. There's our new vertex. And there's those 2 inner points. If I wanted one more point, over 1 up 3, over 1 up 3. And it would end up looking about like that. Same thing here, x squared shifted right 4. So it's going to be the same shape over and over. Shifting it right 4, I'd move over 4. There's my new vertex. And then there's those matching points to the side. Again, over 1 up 3 if I wanted a couple extra points on that for drawing on paper. And there we go. For the computer, it will just need vertex and 1 point, though. Sketch the graph of y equals x squared shifted right 5 and down 4. So right 5 would be right there, and down 4 would be right there. And then we were over 1 and up 1 on both sides. Again, over 1 up 3 if we cared. And there's our graph. For this one, I'm just going to write out what that would look like. Y equals, it would be x minus 5 quantity squared minus 4. And so earlier we had the HK there, saying that was the vertex. So it's x minus h, which means this is the opposite if we were trying to find the vertex of this. So it would be 5. And again, that's because if when we see the formula has x minus h in there, so if I plug in a negative, or if I plug in a positive 5, it's going to show as a -5. It's the same thing that makes it shift right, even though it has the minus. So anyhow, 5 and -4 would be the vertex. So what we've been thinking is our left, right, and our up, down. In this case, it is also the vertex of the parabola. For this one, we're supposed to reflect across the x-axis and shift down 6 units. So if I reflected this, do that much, it would be right there. And then if I take that picture and shift it down 6 units, it would be starting here and still having that same exact shape. So it would end up looking something like that. This one we're reflecting across the x-axis and shifting right 5 and down 3. Okay, so our shape would be this, would be our reflection, and then we're going to draw that shape shifted right 5 and down 3. So that would be right there, and there's be those two corresponding points. Vertically stretched by a factor of 4. Okay, so let me draw a parent function in here. And then if I stretch that by a factor of 4, the vertex would stay the same because 0 times 4 is still 0. But normally when I put in, if I have y equals 4x squared, if I put in 1, instead of getting out 1 like I do for the parent function, it's going to be 1 times 4. It's just going to make that 4 times taller. So that's our vertical stretch. We'll do the same thing on the other side. This will be a little hard to draw, but something kind of like that. This one is vertically stretched by a factor of 3 and shifted down 4. So we would be starting down here at negative 4 for the shifted down 4. And same as up here, instead of going over 1 and up 1, I went over 1, up 4. This one's going to go over 1 and up 3 because it's stretched by a factor of 3. So those inner 3 points make the stretches actually pretty easy because whatever the factor is, that's the new height. And then, again, something kind of like that. Vertically stretched by a factor of 4, reflected across x, and shifted left 2. Okay, so we'll go left 2, and I'm going to open down instead of opening up, and since it's stretched by a factor of 4, it's going to be over 1 and down 4 to that next point instead of the over 1 and down the usual 1 to that point. And I get something like that. For these last two, we're asked to write the equation based on the graph rather than giving the verbal description and graphing. So y equals, this one, let's take a look. So there's our vertex. Just actually get rid of that for a second and write that out. So our vertex is at 2, negative 1. And our vertex, and then our next point is not 1, 1, so there's some kind of stretch on here. It's not over 1 and up 1. So when I come up here to the next clean point, then I can see that this goes over 1 and up 3, so that means this has been stretched by a factor of 3. It's opening up, so it's a positive 3. And then x minus h, the h coordinate of the vertex is 2. And there's that minus 2 showing when it's a plus 2 in terms of the coordinate. And don't forget the squared there, so it's actually a parabola. And then it's been shifted down 1. For this one, so this one does not have a stretch because it's going over 1 and down 1 to that next point. And our vertex for this is negative 3 and negative 1. So y equals, it is opening down, so that's going to put a negative in front of the parenthesis. You could have a negative 1 there. Usually we just write a negative. X, and then it's minus negative 3, because the formula has the minus in it. It's x minus h. So then that shows us that plus 3 that we've gotten used to when we see a plus 3 inside, moves left, and then down 1. And that is graphing using transformations.